Not all angles are the same. Some are obtuse, some are acute. But not all obtuse angles are the same. Some angles are wider than other angles. How do we say how wide an angle is? We would need to measure it. How could we measure an angle? Let's look at a clock. The hands on a clock can make every angle there is. Okay, let's make something like a clock with hands. But it won't be telling us what time it is. It will tell us how wide an angle is. What kinds of angles? How about this green one and this blue one? What about this red angle? That's bigger than the angles you might usually think about, but maybe our measurement system should let us measure those angles too. They could come in handy. Now the numbers. To measure something, we need numbers. Let's start with 0. What would an angle of 0 look like? How about this? When the hands are covering each other, there is 0 space between them. Here's another question. What is the biggest angle there could be? That would be the angle that goes all the way around the whole circle. So what number should we give that? Well, let's try 100 and see how that works. If the whole circle is 100, half the circle would be half of 100, which is 50, and 1/4 of the circle would be 1/4 of 100, which is 25. How about 1/3 of the circle? 1/3 of 100 is 33 1/3. That's inconvenient. It would be nicer if we could avoid fractions. Okay, how about 60, like minutes in an hour? Now half the circle is 30, 1/3 is 20, 1/4 is 15, 1/5 is 12, and 1/6 is 10. That's good, but these marks are still pretty far apart. What if we want to be more precise? To measure more precisely, we need more than just 60. How about instead of dividing a circle into 60, we divide it into 360. That's 60 times 6. If the whole circle is 360, half the circle is 180, 1/3 is 120, 1/4 is 90, 1/5 is 72, 1/6 is 60. Now we can measure angles really precisely. 360 is the number of angle units people started using. What did they name these units? They called them degrees, and that's what a degree is.